All right, good morning. Welcome back to Calculus 2. So we have this series n goes from 1 to infinity of n squared over 2 to the n. And we're going to see whether or not this thing diverges or converges. Okay. So in this case, again, we should use the root test or the ratio test. You might be tempted to use the ratio test, and it's not a terrible idea, except that this 2 n squared thing, that's not going to get rid of that 1 over n thing. So we're going to end up with an n squared to the 1 over n. That's going to be a little tricky to kind of deal with. So I think an easier way to go would be, let's try the ratio test. Okay. So what we're going to do is we're going to test the absolute value of n squared over 2 to the n. Okay. And we're going to actually, we have to do is we have to test the absolute value of the a sub n's here. Let me go ahead and restart this guy right here. So we're going to be looking at n plus 1 squared over 2 to the n plus 1. And then we're going to divide it by n squared over 2 to the n. So we're taking the a sub n plus 1. So we're going to look at this divided by a sub n. That's like the idea of what we're trying to do here. Okay, without writing down all the details. And then once we've evaluated this, we're going to take our limit as n goes off to infinity to see what happens. And same thing with the root test. If my limit is greater than 1, then we diverge. Okay. If the limit is equal to 1, then the test is inconclusive. Okay. And if the limit is less than 1, then we will have converge. Okay. But we'll say converge absolutely because we are dealing with absolute values here. Okay. And that's pretty much what we are looking at for that one. Okay. So let's go ahead, and we have a little bit of algebra to do to figure out what's going on with what's happening with this. So we'll go ahead and we'll say, okay, we have n plus 1 squared. Okay, so we have n plus 1 squared over 2 to the n plus 1 divided by n squared over 2 to the n. Okay, so we're going to have a complex fraction here. We'll have to deal with this thing. I'm going to go ahead and multiply some of this stuff out. So we have this is equal to n squared plus 2n plus 1 divided by, now rules of exponent, 2 to the n plus 1 is 2 times 2 to the n. So that's what this means. And then we're going to say divided by, and here we have n squared over 2 to the n. Okay, what's the help of it all? Is that video on? Now, what we're going to do here is we're going to invert and multiply. So we have 2 to the n over n squared, 2 to the n over n squared. Okay, and we're just going to go ahead and deal with this fraction. The whole point of inverting and multiplying is that this whole bottom section cancels out, and that's kind of what we want. Okay, and then what we're going to do with the top is, well, the 2 to the n's cancel. We're still left with the 2 down here. And we have, let's go ahead and look at this. So we have an n squared plus 2n plus 1 divided by 2, and we're multiplying this by 1 over n squared. Okay, that's pretty much what we have for this piece right here. So I want to take my limit as n goes off to infinity, but we're going to go ahead and factor in this 1 over n squared here. So that's going to be 1/2 times. Now, multiplying this by 1 over n squared, we're going to say this is 1 plus 2 over n plus 1 over n squared. And we're taking our limit as n goes off to infinity. Okay, going back to calculus 1, I know that these pieces are 0, this piece is 0. So we pretty much have that this whole thing here, this limit, is equal to 1/2. And I'll go ahead and write 1 plus 0 like that plus 0 like that. Okay, as we've taken our limit. So this is going to be equaling 1/2. Okay, 1/2 is smaller than 1. So we know that this series converges, and we'll say converges absolutely by the ratio test. The series converges absolutely by the ratio test. Okay, and that's pretty much how you do a problem like that. Okay, so thank you very much for watching the video. I'll see you next one, and take care until then.